Assalamualaikum and hi. We are from Group 1 want to present about microwave assisted titanium nitride coating processing using nitride powder in ambient atmosphere. My name is Anwar bin Ismail and my teammate is Wan Abdul Hafiz and Erico. For introduction, some of interstitial site of titanium are occupied by titanium nitride and interstitial solid solution of nitrogen. According to R. Castillo, titanium nitride coating can improve fibroblast cell proliferation, adhesion, and differentiation, as well as decrease bacterial adherence and biofilm formation. In chemical vapor deposition, the titanium nitride coating film is deposited by the following reaction: titanium chloride, nitrogen, hydrogen, titanium nitride, and hydrogen chloride. Chemical vapor deposition (CVD) and physical vapor deposition (PVD) are carried out of large-size products in order to make the process cost-effective. Experimental method. Simple setting. Initially, two types of raw titanium powder which had different particle size, 99.9% purity 45 micron passed and 99.9% purity 150 until 250 micron. This two powder is termed mixed titanium powder. A quartz test tube was used as the container, diameter 23 mm out dimension and 20 mm in dimension. There was a diameter 10 mm hole at the bottom of the tube. In the titanium powder method, the titanium 6A14V substrate diameter 14.5 was buried in mixed titanium powder. The sample was heated with a 2.45 GHz microwave heating equipment. The temperature at the top of the packet powder was measured using the radiation thermometer. Temperature control. The microwave power was set to 100 watt at the start of irradiation. The power was controlled to increase in 100 watt step every minute. The temperature was then kept at either 100 degrees Celsius, 900 degrees Celsius, or 1000 degrees Celsius for 45 minutes. Analysis. The coated film was characterized by X-ray diffraction (XRD) and scanning electron microscopy (SEM). The physical properties of the coated film were measured by using Vickers hardness meter and a surface roughness tester.
Alright, I will continue the result and discussions. For the table below, show that figure 1 sample setting titanium powder method, B titanium powder method, C microwave heating equipment, and D the photograph of the susceptor and thermal insulator. Figure 2 profile temperature and microwave irradiation powder during titanium powder method, and B titanium nitride powder method at 900 Celsius. In both the titanium powder method and titanium nitride powder method, the same temperature could be maintained with almost the same microwave irradiation power. In figure 2, after the temperature reached about 500 Celsius, it immediately rose above 1500 Celsius in both cases. This rapid temperature change was also seen at other temperature conditions at 800 and 1000 Celsius. This behavior seems to be thermal runaway in figure 2, indicates that temperature change of the upper parts and the sample behave similar in both cases. However, its inner temperature of titanium nitride powder seems to be lower than titanium powder. It is surely difficult to measure at inner temperature, but SEM image can give some indications as discussed later in this section. Alright, now figure 3 shows XRD pattern of each sample produced under various temperatures. Show that nitride-based paste was synthesized after microwave irradiation. The synthesized paste included 2 or 3 titanium pastes, which is TINX and TI2N and FCCTIN1, and these peaks were brought compared to substrate peak. From the TIN phase diagram, TINX was generated when the N content was small and it increased, and Ti2N and FCCTIN is generated. Thus, enriched phase should mainly observe when process temperature increase. The intensity of FCCTIN increase with increasing holding temperature in both methods. On other hand, the XRD exhibited with TINX and FCC titanium nitride phase show existed at 1000 Celsius process.
Figure 4 shows the viscous hardness of each sample produced under various temperatures using the TI powder method and the TIN powder method. Table 1 shows the value of hardness and roughness of each sample produced under various temperatures using the TI powder method and the TIN powder method. In table 1, RA means arithmetic mean roughness, the absolute average relative to the base length, and RZ means maximum height of the roughness profile. Figure 5 shows the roughness of each sample produced under various temperatures using the TI powder method and the TIN powder method, and shows the roughness curve of each sample and summarized in table 1. All roughness curves of the TI powder method exhibit some peaks, as the height of the peaks were on the order of several micrometers. They evidence the existence of TI Coulson gram as shown in SEM image later in figure 6. As the figure 6 shows, photograph and SEM image of each sample produced under various temperatures using the TI powder method and the TIN powder method. Therefore, in the powder, in TI powder method, a circular structure was observed regardless of the holding temperature, but it was not seen in the TIN powder method at 100 degrees Celsius or 900 degrees Celsius. As mentioned in the introduction before, the TIN coating mechanism is tough to be due to thermal deposition or sputtering of the raw powders. In addition, there is a possibility of hot spots due to the strong electric field generated between the raw powders as the cause of the thermal runaway, and the plasma generation due to this strong electric field is also considered to be sufficient. On the other hand, in both mechanisms, it is considered that the TIN coating progressed excessively due to the thermal runaway. In other words, the TI powder method excessive coating progressive result in the problem of rough coating film. In the case of TIN, thermal runaway was suppressed around the substrate. From this result, the TIN powder method at 900 degrees Celsius result in the fabrication of the sample with the highest hardness and the lowest roughness. For the conclusion, a TIN coating was successfully fabricated using a novel TIN powder method that utilized microwave in air. The TIN coating film synthesis at 1000 degrees Celsius had sufficient hardness, but its roughness was high for both methods. In contrast, the TIN coating film synthesis with the TIN powder method at 900 degrees Celsius and 800 degrees Celsius were both smooth, especially at 900 degrees Celsius. The TIN film generated exhibited a high hardness of 697 Hb with Ra equal to 0.29. This result demonstrates that a hard and smooth TIN film can be obtained using the TIN powder method by decreasing the energy of the exothermic reaction between the raw powder and air, which can prevent excessive TIN coating progress. The concept of the TIN powder is one of a strong candidate to control of the runaway or plasma formation, and this method is expected to be applied for TIN coating on a implant of titanium-based alloy. Okay, that's all from our team. Thank you for your attention.